Okay, example 12, similar setup. Again, difference of two numbers is 14, very similar structure of the equation that the other problem was. But then the second fact, the larger number is 3 more than twice the smaller number. That's a little bit more creative in how they wrote it. It says find the two numbers. So once again, we start off with the find the two numbers question. We can see they've given us wording to write two equations, allowing me to write two variables. So x is one number, y is the other number. I typically stick to x and y unless they give me some reason to use a different variable. They start talking about like girls and boys, maybe use G and B, whatever, but just finding general numbers, x and y serve their purpose well. So first fact, the difference of the two numbers is 14. Again, it's a positive 14. If I want a positive difference, once I write x minus y equals, I've already established x is the bigger number, y is the smaller number. Could have just as easily written y minus x equals, doesn't matter. But since x minus y equals a positive 14, I know x is the larger number and y is the smaller number. Anytime you write a different structure like that, just simple one number minus the other, you establish size of numbers in comparison to one another. X must be bigger than y. Okay? And the reason that's necessary to know here is the second fact says the larger number is. All right? So the larger number is, that's x equals 3 more than. Anytime you see more than or less than, I usually ignore it to the very last thing. So I'm just going to circle that. It's important, but not yet. Twice the smaller number. Twice means 2 times the smaller number is y, so 2 times y. And it's saying this number x is 3 more than this product 2y. X is 3 more than 2y. 2y is smaller by 3. So plus 3 on that side gets them equal. So for example, 9, 6, right? 9 is 3 more than 6. We have to add 3 to 6 to get 9. So we have to add a 3 to the smaller side in order to get the bigger side. That's kind of how you want to deal with. And typically, is the equal sign. The word 3 more than happens after the equal sign. So you put a plus 3 after. It said 3 less than, you put minus 3 at the end. So typically, that's the easiest way to go about doing that. And then once we got that set up, once again, we have to look at the system of equations we made to establish what's the best technique for solving this. This has x minus y equals 14. This says x equals 2y plus 3. When one variable equals something else, it's much easier to just do a substitution. So I'm going to put 2y plus 3 in place of x, because that's what x equals. So the top equation, which says x minus y equals 14, becomes 2y plus 3 instead of x minus y equals 14. And just like that, x disappeared. I got a couple of y values. I got a couple of numerical values. I simply solve it using basic algebra. I'm going to move my 3 to the other side. It becomes negative 3. 2y minus y, which is 1y, makes 1y, which is y. 14 minus 3 makes 11, so y must equal 11. X minus y equals 14. I can either go here, change that y to an 11, or I can go here, change that y to 11. It doesn't matter which one I go to. I'm going to go to both just to see that we get the same answer. So it says x minus y equals 14, so x minus 11 equals 14. We move the 11 to the other side. X must equal 25. If I go to the bottom equation, x equals 2y plus 3, but instead of y, I'm going to put 11. Order of operation says multiply first, and 22 plus 3 is 25. Either way we do it, we got x equals 25. So again, it really doesn't matter which one you go back to. In this case, they're both pretty simple, so going back to either one's fine. It would be fine. It says find the two numbers. So again, it asks us to find the two numbers. They're 25 and 11. Again, there's no meaningful reason for an ordered pair in this problem, so we just write the answers as is. 11 and 25 would have been just as fine.